class, let us see the problems based on that. So actually, if you understand that riverboat concepts clearly, you can solve any problem related to that, right? And so now let us see some of these problems based on these riverboat concepts here. And so now here let us see this first problem here. So then this is a man can row a boat with 4 km per hour in still water if he is crossing the river where the current is 2 kilometers per hour. In what direction will his boat be headed if he wants to reach the point on the other bank directly opposite to the starting point? So that means by reading this question itself, we need to identify which case this is. We already discussed some cases there, so we need to identify that which case is it. So directly reaching the opposite point means then that is nothing but shortest path, right? So that means he has to reach the shortest path there. So then if width of the river is 4 kilometers, how long will the man take to cross the river with the condition in the part A? So that means in this condition they are asking that what is the time taken to cross the river in the shortest possible path. The next one, what they are asking is in what direction he should head if the boat if he wants to cross the river in shortest time, and what is this minimum time. So they are asking that in which direction he should start the journey for this crossing the river in shortest possible time, and also they are asking that time. And so how long will the man take to row the 2 kilometers up the stream when the then back his stream starting point. So that means whatever the cases we discussed, almost all the 3 cases are there in this problem. So that means in the last class we discussed shortest time, shortest path, and up the stream and down the stream. So almost all the 3 cases are there here, right? And so now this is nothing but we know that to cross the river in shortest possible path. So we know this, if this is the starting point, for example here, then if we want to cross the river like this, if we want to reach this opposite point here, and starting from here, we know this, he has to start his journey along this direction here, right? So this is the direction in which he man should start this, and so that this value is nothing but you can take this as velocity of the river you can consider here to reach this directly opposite point here. And so now this is suppose say point A, this is point A and this is the point B and this is the point C here. And we know the sine theta value is given by the sine theta. This is the theta value if we consider here. This is with the normal then. So then sine theta is nothing but in our discussions we consider that as a phi. There is no any confusion in that. You can take any angle here. Here they are taking that as a theta. And so I am taking in terms of this theta here. So then opposite side. This is nothing but our VR direction. And this is nothing but our VBR direction here. So that this velocity of the boat with respect to the ground will be along this direction here. So that person will reach the directly opposite point. And so from this we can write this as sine theta is nothing but VR by BBR. We can write this is the direction which the boat should start its journey in order to reach the directly opposite point. Just they are substituting this value so that you will get this theta value is equal to 30 degrees, right? That means 30 degrees with the normal to the direction of this river flow. With the normal to the direction of the river flow. If you want to answer with the direction of the river flow, then we need to add this total angle here. This total angle is nothing but our angle with the direction of the river flow. With the direction of river flow, then 90 plus 30, 120 degrees. That means with the direction of river flow, the man should start his journey at an angle of 120 degrees with the direction of the river flow. And next in this case, they are asking the time taken here. And we know already this how to calculate this time taken here. So the time taken is nothing but this direction we need to write here. So we derived an expression for this time taken as T is equal to that width of the river by actually which is nothing but VB we need to write here, or which is nothing but you can write this as D by VBR cos theta. If you are taking that with the normal as a theta there. So either of these values you can substitute here, or we also mentioned a formula like this value we can write this as by using Pythagoras theorem. In the discussion in the last class we derived already this expression VBR square minus VR square. So you can apply this formula. As we already calculated this theta value, you can also use this value here. VBR is known to us 4 and this theta value is 30 degrees. So directly can you also substitute here, or otherwise you can substitute in this expression here. And so that we are getting the time taken as 2 by root 3 hours. So that is the time taken to cross the river when he is reaching this directly opposite point, right? And so then next case is like they are asking in which direction the person should start his journey to cross the river in shortest possible path. So shortest possible time. We know if you want to cross the river in shortest possible time, he should he should start his journey normal to the direction of the river flow here. This we already discussed there. All these are standard cases only. So then the person will reach this point here. So this is the direction of this. That means this is our VBR, velocity of boat with respect to the river should be along this direction. This is the VB resultant velocity and this is VR here. So that means the person should start his journey normal to the direction of the river flow here, right? So that is nothing but this theta value with normal to the direction of the river flow. Theta value is 0 they are taking. So theta means here you should observe that this angle they are taking as theta with normal to the direction of river flow. So that angle they are saying it as 0. That means it is nothing but we should answer it as the person should start his journey normal to the direction of the river flow. And then from this you can directly write this value as T by the time taken for this, the minimum time taken is nothing but we know this D by VBR here. So that is 4 kilometers by 4 kilometers per hour you can substitute, so that you will get this value as 1 hour here. So that is the direction, that means that is the time taken in that case. And the next case what they are giving here is see this question here. How long will that take? It takes him to row 2 kilometers up the stream and then back. So first he is traveling up the stream here. So when he is traveling up the stream, then the directions will be like this. Here it is shown here. So the direction is like this. When the river is flowing down and he is traveling up the stream here. And when he is traveling down the stream, then the direction resultant velocity will be VB R plus VR. This is nothing but our resultant velocity here. So this is nothing but our VB, we can write these values. So this is the case when he is traveling up the stream, and this is the case when he is traveling down the stream. So these are the resultant velocities. And so now simply you can write that as distance by resultant velocity we can write here. So CD by resultant velocity when he is traveling up the stream. Plus this distance by resultant velocity when he is traveling down the stream. So directly these are like formula substitutions only, which we discussed already, right? And so now let us go to the another problem here. So all these are similar models only. The data they will give in different ways. That's why I am taking all these examples here. So now let us see this data here. A man wishes to cross the river in a boat. If he crosses the river in a minimum time, he takes 10 minutes with a drift of 20 meters. If the man crosses the river taking the shortest route, it would be 12.5 minutes. Find the velocity of the boat with respect to the river. So that means here again in this problem also those two cases are mixed here. Shortest path and shortest time case are mixed. So that means here velocities are not given. There is no information about the velocities, but the time taken in both the cases are given. So directly you can use the time taken formula which we derived already, and from that you can calculate those values here. And so now here time taken when he is crossing in the minimum time is given here. So minimum time means we know the time taken will be minimum when VD velocity of boat with respect to the river is directly perpendicular to the velocity of the river. So this value is given for us. And so then this value is nothing but 10 minutes is given here. I am substituting in minutes only, later you can convert there if you want to convert it into seconds. And the drift in this case is given here. The drift is nothing but we know velocity of the river into, in this case, velocity of the river into the T minimum you can write here. And so now this velocity of the river into this drift is 120 is given, 120 meters. And this time taken is 10 minutes is given here. So therefore from this what we can write is 12 meter per minute you will get, or if you want to convert that into seconds you can substitute this as 60 seconds you can substitute here, right? And so that this value will be 1 by 5 meter per second you can write. So that is velocity of the river. And the another information is given, if we want to cross the river in shortest possible time, then he is crossing in a time of 12.5. So that means now this value you can write this as time taken to cross the river in shortest possible path. This time also we derived already. d by under root of VBR square plus VR square. So directly I am using the formula which we derived here. And so from this I can write this as VBR square minus VR square is equal to T by D whole square. And from this we can find this VBR is equal to under root of VR square plus, this is VR square plus T by D by T whole square. This T is the time taken when he is crossing along the shortest possible path, shortest route. Now we can substitute these values here. You can substitute all this data given here, and so that you will get that required value there, right? And so then here actually in this data you can observe that that the d value is missing there, so you can use this d value by using this time taken equation here. So as this value, from this you can substitute, you can convert this d value in terms of VBR. So this is 10 minutes into VBR you can write here, so that that equation will convert into VBR here. So that from that you can calculate actually this VBR value there, right? So here d is also unknown here. So you can write this expression as dBr value, you can substitute there. So that means what I am saying is this value is VBR square minus this value I am writing this side here minus 10 by VBR into T. This T is nothing but 12.5 whole square. D by T value I am substituting here. This is equal to VR square. So then simplify this, then you will get this VBR square value here. That means VBR square you can take common. Then 1 minus 10 by 12.5. Here it is, whole square is there here for this, is equal to VR square. Now substitute this VR from this and simplify this equation, you will get this VBR value. So that VBR value is nothing but 20 meter per second you will get here, right? So that is those values there. And now let us say this another problem here, next problem. So you can observe this, these problems are directly based on these formulas only, those simple cases only. You can, if you identify those cases, you can easily solve these problems here, right? So now a man can swim at a particular rate of 5 kilometers per hour in still water. So in still water means, I said in the last class itself, still water is nothing but you need to take it as with respect to the water, right? So sometimes they will give it as with respect to the water, or sometimes they will give it as still water. So that is nothing but with respect to the water. So a 1 kilometer wide river flows at a rate of 3 kilometers per hour. The man wishes to swim across the river directly opposite to the starting point. Along the what direction he must swim, the man swim, what should be his resultant velocity, and how much time will he takes to cross the river. So these are also like the previous formula only. You can directly solve this. So here additionally they are asking the resultant velocity. Resultant velocity is nothing but VB value you need to calculate here. You can directly use this formula here, our sine formula. That sine theta is nothing but you can write this as our sine phi is equal to, we can write this as our general formula I am writing here, VBR by VR, where this phi is nothing but this angle here. So angle with the normal to the direction of the river flow. And so then from this you will get the phi value, and from this you can write the theta value with the direction of the river flow. So pi by 2 plus phi value you can write. And the next time taken they are asking here. Then the resultant velocity they are asking. The resultant velocity is nothing but VB. And so by using this right angle triangle, you can write this value as VBR square minus VR square. So that is the resultant velocity. And time taken value we can write this as d by VB value we can write here, as we calculated this VB value, or we mentioned this direct formula as under root of VBR square minus VR square, right? So which we discussed already. Again the formula based question only. And so now let us see this another question. A river flows due to south with a speed of 2 meter per second. A man steers a boat across the river. His velocity relative to the water is 4 meter per second due to east. The river is 800 meters wide. What is his velocity, the magnitude and direction relative to the width? How much time is required to cross the river? how far south of his starting point will he reach the opposite bank. So that means now his velocity relative to the his crossing, that means here also the direct formula based only, that means they are giving the information in a different way. In a different way means the river is flowing south here, you need to observe this, which case it is you need to observe here. The river is flowing south here. When the river is flowing south, you can observe that when the river is flowing south, the man is steering towards east. That means the man is traveling towards east. So that means the man is traveling opposite to the perpendicular to the direction of the river flow here. So that means now this is the case. This is the directions here. This is our VR direction. VR is towards south here, and then this VBR is along this direction. That means that this is the case of shortest time, right? For this shortest time only, man has to cross this river perpendicular to that. And so now the resultant velocity is nothing but you need to consider this resultant velocity here. One is along this say x-axis and other is along this y-axis according to this. So we while discussing we consider the different way, like river flow direction we consider as x-axis. So here according to the given information, this river is flowing along this direction. You may consider this as some y-axis, y direction here. So finally we need to write this resultant velocity as under root of Vc square plus Vbr square. We need to Vr square plus Vbr square you need to write here. The resultant velocity is nothing but, right? So that is the resultant velocity here. Remaining you can calculate directly by using our formula. So Vbr square plus Vr square you can write. So remaining these two is time taken to cross the river and how much south of his he will how far south of his starting point will he reach. That means that is nothing but you need to calculate time taken and you need to calculate the drift values, right? So you can calculate directly by using formula. So calculate those values by yourself and check these values here. I am giving the values here. I mentioned these values also here. So check those values there, right? So all these are formula based questions only. You need to check, you need to identify the case. That means all these problems they are giving the different information in a different way, right? And so now let us see this series one. So series question here. This question is in which direction should the motor boat given in the illustration 5.46 head in order to reach the point on the opposite bank directly east of the starting point? The boat's speed relative to this water is. So next say this is also like our previous case only, previous problem only. So once I will explain the data, you can solve this problem also. In order to reach the directly opposite, in which direction should the motor boat given in the illustration head in order to reach the point on the opposite bank directly east from the starting point? The boat speed relative to the water will remain 4 meter per second. What is the velocity of boat relative to the ground and how much speed, how much time is required to cross the river? So I think you got the data which we need to calculate. The boat is crossing along the shortest possible path because he has to reach the directly opposite point from the starting point. So here he is starting from O and he has to reach the point B here. So that means in order to reach the directly opposite point, so that is the meaning of this directly east from the starting point. So from this, if the point B is directly east. So in order to reach this point, at what angle he should start? We know the sine theta is nothing but VR by VBR, and from that you can calculate this time taken and resultant velocity they are asking here. Resultant velocity is nothing but VB value, which is nothing but under root of VBR square minus VR square. So right, so that means calculate by yourself and you can check these data values here. Your answers you can check here. And next write this series problem. A boat moves relative to the water with a speed v, which is n times less than the river flow velocity u. At what angle to the stream the direction must boat to move to minimizing the drift? So this also we discussed here. So that means here this is the case of, you can identify here, this is the case of the velocity, the boat moves with a velocity v, which is n times less than that of this. That means in this case our VBR value is less than this VR, right? So in this case, if you want to decide for the minimum drift to reach the opposite point, if you define the sin theta or sin phi expression here, so which is nothing but we write this as VR by VBR. So this also we discussed minimum drift case. So that means now this value you will get this greater than 1, so that directly reaching the opposite point is not possible, as we discussed in the last class, right? So then in that case, to minimize the drift also we discussed already in the last class. So that means the total derivation they are giving here, as you know, you can directly calculate that expression here. So that means for this you can calculate this expression as, in this case, our expression will be VBR by VR. So this we derived already in the last class for minimum drift under this condition. So then this is nothing but that value here. So VBR value is given as n times less than that of VR value. So then you can substitute those values here. So that, sorry, this is sin phi value, so that this value we can write this as 1 by n value we can write here. So right, so that is that angle in which the person should steer his journey here. So then here the total information, total derivation is given, as we know already that formula, directly applied that formula, right? So once again go to that derivation and revise that. And this also directs such a formula, such a problem only. So again here solve by yourself. I will explain this data about the moves relative to the water with a velocity which is eta, that means 2 times less than that of river flow velocity. At what angle to the stream the direction must be the boat move to minimizing the drift. So that means here also the such a similar formula. The answer you should get it as 60 degrees, 120 degrees with the direction of the stream. That means direction of this river flow. So that means this also same as that of previous formula. Apply that formula there, which we discussed there. And so now let us see this another problem here. A swimmer cross a 200 meters wide channel with a straight bank and return in 10 minutes to the point 300 meters below the starting point down the stream. Find the magnitude and direction of the velocity of the swimmer relative to the bank. If he heads towards the bank to the channel all times right angles. So right angle. So this is another word which I said in the last class. So they will give the information like the swimmer keeps always himself right angles to the direction of the river flow. So direction of the right angle to the direction of the river flow means that is nothing but the person is traveling along the shortest possible path. In that only that VBR direction will be perpendicular to that VR direction. VR direction you will get. So that means this is our VBR direction here. The VBR is along this direction. So this is our VR direction. So the velocity of the boat will be along this direction with respect to the ground. So here the given information is he is crossing the river and again comes back here. Comes back but by a distance of 300 meters. So this is the 300 meters down the stream in the direction of the river flow. He is coming down here. That means say he is reaching this point here and again in the return journey he is reaching this point here. So in both the cases it is mentioned that always he keeps himself normal to the direction of the river flow. That means either to reach the opposite bank and again coming back to this original bank. So in both the cases he is traveling along the shortest possible time only, right? So that means just you can apply the formula here. That means in for one journey either to cross the boat you can consider this drift as half of this, because both the journeys are similar here. So you can take this drift as 150 meters here. That means for one journey this will be the drift. So this value you can take it as half of this. So 150 meters you can consider here. So the drift value. So the displacement perpendicular to the direction of the river flow is given, and from this you can calculate here. And the total time is 10 minutes is given. So for one journey you can take this value as time 5 minutes here. That means our time taken is 5 minutes. 5 minutes for one journey, say for starting from point A and reaching the point C here. Suppose this point is D. And now this velocity of this time taken formula we can write this as in perpendicular case D by VBR value we can write. So therefore this VBR is equal to, you can write this expression as the width of the river is 200 meters is given. So it is 200 by 5 into 60. Then you will get in meter per second, so which is nothing but you can write this as 2 by 3 meter per second. So that is our VB value. And then next they are asking about find the magnitude and direction of the velocity of the swimmer relative to the bank. So that's they are asking that value only, and from that you can also calculate like VB value you can calculate, and VR value, that means VR value we can calculate, and velocity of the boat with respect to the ground you can calculate here. Now this to calculate this VR value you can use our drift expression. Drift in 5 minutes if you are taking, then it will be 150 meters you should take. And if you are taking directly in 10 minutes, you should take the total drift. If you are taking the total time 10 minutes, then you should take this total drift here. So this is 10 minutes if you are taking 10 into 60. Then if this value should be 300. Or if you are taking here 5, here also half we should take here. So this is VR into 600 you can write. And from that you will get this VR is equal to 1 by 2 meter per second. And if you know these two values, these two are perpendicular to each other, you can observe this situation here, these two are perpendicular to each other. Then from that VB value you can calculate under root of VR square plus VBR square. And this direction also you can calculate here because they are asking the direction also. And so next series problem here. So two swimmers leave the point A on the bank and reaches the point B lying right angles to the other bank. One of them crosses the river along the shortest straight line AB, while the other swimmer at right angles to the stream and walks the distance that he has been carried away by the stream to get to the point B. What was the velocity U of the man walking if the both swimmers reach the destination simultaneously? The stream velocity is 2 kilometers per hour and the velocity V dash of the each swimmer with respect to this water is equal to 2.5. So here got the information. That means there two persons are there, they are starting from the same point and they want to reach the directly opposite point. So one is deciding to cross along the shortest possible path here, right? So that is one of them crosses the river along the straight line AB. That means he is directly reaching this point. So that means say first person A. So he is reaching directly this point means he is crossing along the shortest possible path. And see the while the other swims at right angles to the stream. So right angles to this stream means then that is nothing but he is crossing the river in shortest possible time. So then, but he doesn't reach the point B here directly. So he will reach some point C here, right? So when he reaches the point C, then he has to walk this distance here to reach the point B. So they are asking with what velocity this person should walk this distance or to run this distance so that both the persons reaches that point B simultaneously. So that means both are reaching that point at the same time here. That is a condition given here. So for this shortest possible path, you can write this velocity here. That is directly formula, time taken formula you can write here. So that means it is B by under root of V dash is nothing but our VBR here. So here they are giving it as V dash. So this is nothing but our VBR, and V naught value is nothing but our velocity of this boat here, river. So VR value is nothing but 2 kilometers per hour. And this velocity of boat with respect to the river is nothing but 2.5 here, kmph. This is nothing but what in this problem they are giving the notation like V naught and V dash. So that is the notation what they are using here. And so then in this time, because this is the maximum time here, this person will reaches this point here. So then in this time the person has to cross the river and he has to walk this distance here. And again for this person you can write the expression for time taken by this man to travel from A to C, that means to cross the river. So then in the remaining time, if suppose this remaining time, this time let us take it as T2, then in the remaining time T1 minus T2 he has to cross this, he has to travel this distance here. So now you can apply this formula like this. The time taken by the man to cross this river is nothing but if you are taking this as T, then this is nothing but our D by VBR we need to write here. So which is nothing but here it is given as B by VB V dash according to this problem here. So in this time, so then it is time taken to cross this person, we can write this as this value. I am taking it as suppose say T2 value because the first one we are considering it as T1. So now this total time we can write this as, suppose he is taking for this walking, he is taking a time of T3 here, for example. This is T2 what we are taking here to reach this opposite point. Then what we can write is, this T1 is equal to, T1 is the time taken by the person who is traveling along the shortest possible path. So this T2 plus T3 we can write here. So from this we can calculate this T3 value. T1 minus T2 we can write here. T1 and the T2 values we can substitute by using the above expressions. Now this T3 value must be equal to this drift x by this velocity of this man we need to write here. Velocity of the man, walking man, who is walking on the bank. Therefore this velocity of the man you can express this as x by this x is nothing but velocity of the river into the time taken T2 we need to substitute here. By this T3 we need to write. So got it? That is the procedure to solve that values, and those values are mentioned here. That means this is drift value first they are expressing here. So this is the drift. Now this total time taken by the second swimmer is nothing but this one. This is the T2 plus T3. This value must be equal to the time taken by this first person here. So by equating them, you can calculate this velocity of this man here. U value you can calculate here. The velocity of the man they are taking it as U. That U value you can calculate here, right? So that which is nothing but 3 kilometers per hour. That means on the bank he has to run with a speed of 3 kilometers per hour. And so next, say this problem here. Two boats A and B move away from each other from a point anchored at the middle of the river along the mutually perpendicular straight lines. The boat A moves along the river, and a boat B crosses the river across the river, having moved off the equal distance from the boat returned. Find the ratio of time of motions T and TB. If velocity of each boat with respect to the water is 1.2 times greater than that of steam velocity. That means here the given situation is at some point the boat is at rest here. That means it is anchored at this point here. So one is traveling along the direction of the river flow here. The information given is the A is traveling along the river and the B is across the river. It is traveling perpendicular to the river here. And they are traveling the equal distance and then return there, right? So they travel some equal distance and then returned. So the time taken ratios they are asking here. So that means for this person A which is traveling in the direction of the river flow, here the case is first it is traveling in the direction, that means down the stream, and next it is traveling up the stream. So that means the total time taken we can write it as time taken by the A we can write it as down the stream means suppose it is traveling a distance D. So they are taking here it as L. Let us take the same value here. So then I can write this as L by down the stream means we need to write that as VBR plus VR. We discussed already. Down the stream means resultant velocity we need to write here plus up the stream. After traveling the distance L, again it is coming back here. So while it is returning, you can write this value as under root of L by the resultant velocity is nothing but VBR minus VR we need to write up the stream here. So this is the time taken by the A. You can substitute those values and you can simplify this. Then here you are getting like the simplify this, you will get this value as 60L by 11B you will get, right? Next, time taken by the B. So here it is given that B is crossing the river perpendicular. That means it is given it as across the river. Across the river means you need to take it as perpendicular to the direction of the river flow. So perpendicular to the direction of the river flow means you need to take this as time taken by the B is equal to L by, perpendicular to the direction of river flow means VBR square minus VR square we need to write. It travels the distance and again comes back there. So into 2 we can write here. That is time taken by the B. So then just to find the ratio of these two values, so which is shown here. The ratio is given by this expression here. That means 1.8 we are getting. So simplify those values, you will get that value there, right? So next, so let us see this problem here. This is an important model here. So see this problem carefully, which is different from the previous problems which we discussed till now. The current velocity of the river growing in a proportional to the distance from the bank and reaches the maximum value V0 in the middle. Near the bank the velocity is 0. a boat is moving along the river in such a manner that it is always perpendicular to the current and speed of the boat in still water is u. Find the distance through which the boat crosses the river will be carried away by the current if the width is b. Also determine the trajectory of the path here. So that means here up to now what we discussed is the river flow is constant throughout the river, whether you are at the bank or whether you are at the middle of the river. The velocity of the current VR value is constant we are taking here, right? But in this problem the velocity of the river is goes on increasing here. The velocity of the river is increasing. Suppose if you are taking this as a river here, so that means at the bank you will get one velocity and at the middle you will get another velocity here. And here let us take this coordinate system also I am showing here. So let us take the coordinate system like this. This is our x-axis and this is the y-axis here. And so now here it is given that the velocity of the boat is it is always maintains perpendicular here. So it is such that here you can observe this. A boat is moving along the river such a manner it is always perpendicular to the current direction. That means velocity of the boat with respect to the river is nothing but along this direction here. Velocity of the boat with respect to the river. And so velocity of the river will be definitely along this direction here, but the given information is throughout this it is not v. So in the middle of this the velocity is given as maximum here. So that value is mentioned here. So let us say this. Speed of the boat in still water is u. So this value is taken as u here. Velocity of boat with respect to the water. So in the middle it reaches the maximum value of V0. So that is the given information here. So that means from this what we can write it is we need to derive an expression for this velocity of the river here. So velocity of the river is equal to, it is proportional to this distance here. It is proportional to y we can write here. Or I can write this expression as VR is equal to some k into y we can write. Right, got it? Because it is velocity of the river is increasing here. Here velocity is 0, that means here water almost appears at rest when you are at the bank. And if you are traveling here then velocity reaches the maximum here. So the velocity is different at different points there. And so now here this value k value we are assuming some proportionality constant. We need to find that k value here. So that k value we can find by using this equation here. So then you can write this expression as V0 is equal to k into d by 2. Or it is given as b here, so let us take it as b. So that means the given information is at the middle. That means when y is equal to b by 2, velocity will be v0. So from this you can substitute, you can find this k value here, 2v0 by b. Therefore this velocity of the river we can write this as 2v0 by b into y we can consider here. So this is our k value here. So this is the velocity of the river which we can take it as x component of velocity here. So I am taking this as now from now onwards I am calling this as x component, and this u you can call it as y component here because it is along this y direction here. And so now let us check is there any velocities along the directions or not. And so that now this distance traveled along x direction and distance traveled along y direction we are going to calculate here. So before going to the calculation, let us check is there any accelerations along x direction and y directions. So from this it is clear that there is no any acceleration along this y direction because it is a constant value. So what I can write here is acceleration along this y direction is 0, right? And now let us observe this acceleration, this velocity along x direction is not constant here, it is a function of y. So let us differentiate this value here. So that it means I am writing it as dvx by dt. So which is nothing but our acceleration along this x direction here. So this value you can write this as 2v0 by b into dy by dt, right? So now this dy by dt is nothing but velocity along this y direction here. So which is nothing but our u. Therefore this acceleration along this x direction you can write this as 2v0 by b into, this is nothing but u, got it? Dy by dt value, velocity along this y direction. So acceleration along this x direction is non-zero and it is a constant value. So it is a constant acceleration means you can write this as kinematic equations you can use if it is required. So after calculating this velocity, so that means up to now what we calculated is velocity component along x direction we calculated, velocity component along y direction we calculated, and then acceleration along x-axis and y-axis we calculated here, right? So now let us go to this displacements now. So displacement along this y-axis. So you can write this as along y-axis acceleration is 0. So you can write this value as u into t. So that means velocity along y-axis into t. So right. So that means that the u value we are substituting. That means next along x-axis we are writing here. So along x-axis, this acceleration calculation which we did already. So this is just acceleration calculation here. So then displacement along this x-axis we are writing. So s is equal to ut plus half a t square equation we are writing here. So now we can observe that in this equation, this is initial displacement is 0 because when the person is at the bank, the velocity of this bank along x direction, that means velocity of the river is 0. So that this initial velocity is 0 here. So only half a t square term will be there. A means that value we need to calculate here. So this is the equation for this displacement here. So from this you can write this y square is equal to u into b by v naught into x. So this equation you can observe that this is a parabolic equation here. So this equation is nothing but our parabolic equation, right? So we know already this parabolic equation in projectile motion. So now this is nothing but similar to that equation there. So this is the parabolic equation here. So then the path followed by the trajectory of this boat will be parabola. So that we can conclude here. And next they are asking this drift here. As it is traveling along the parabola, there will be some drift here. So first we calculate up to this midpoint here. This x value we can calculate here. The time taken to reach that point value we can write this as, or you can substitute this directly this y value here. That means from this x value what we are getting this value is v naught into y square by u into b. So that means we need this x value, or let it be x1 when y is equal to d by 2. So v naught by u into b into this is b by 2 whole square we need to write here. So that this value will be v naught into b by 4 into u you can write. So this is the drift, half of the drift here when he is traveling from here to here. That means just we are substituting when y is equal to b by 2. That means up to the midpoint. Then he travels like this. When he travels like this means here also the same drift will be there here. So that means for the total drift we need to multiply this value as this x total is equal to this 2x1 we need to write here. Just we need to multiply that so that you will get this expression here. V naught into b by 2u you will get twice that of this value. So that means this is this problem here. So once again solve this problem by yourself after listening this. So this is a different problem here having some accelerations also, right? And so now let us see this concept here. So in riverboat problems we discussed the different cases like shortest possible path, shortest possible time, and then we discussed a problem like down the stream and up the stream. So that means now the person wants to reach some other point here which is not either directly opposite point or he doesn't want to cross the river in a shortest possible time, but he wants to reach some opposite point, a particular point here. Suppose say observe this here. The person is starting from this point here and he has to reach the point B here. So that means it is not either minimizing the time or not the minimizing the drift here. So right, but he wants to travel a particular direction. So that means in his desired direction he wants to move, right? So for this what we can write here is so simply if you are taking this direction AB, the only concept here is this is VMR. VMR is nothing but velocity of boat with respect to man, or which is our general notation we are taking as velocity of boat with respect to the river. So you can take this as VBR or VBR or VMR. There is no difference in that, right? So that means now we are assuming that the person is traveling along this. That means velocity of boat with respect to the river is along this direction, and velocity of the river is along this direction, but the person wants to travel along this direction. So person wants to travel along this direction is simply you can identify that the boat velocity with respect to the ground must be along this direction. So that is our only the requirement here, so that the boat travels along this line only with respect to the ground and it reaches that point there, right? So that means what our requirement is, velocity of the boat with respect to the ground must be along this direction. So further, how to conclude that velocity of the boat is only along the direction means, so to have that only velocity along this direction. Now what we will do here is, so let us observe this here. Velocity of boat with respect to the river we are taking as it is making some angle alpha with the direction, the desired direction here. and velocity of the boat with respect to the velocity of the river is making an angle theta with this, right? And so that the direction resultant velocity is only along this direction means what we can conclude here is, suppose if I am resolving this into components here, so that is explained here. So let us see this now. So just we are resolving this into components here. This we are taking it as our required direction. Let us take it as x direction here. So that means only here the only simple condition what we can write is, if you resolve these velocities into components, the component of velocity perpendicular to this direction should cancel with each other. So the resultant velocity, our velocity of boat with respect to the river is nothing but, we know velocity of boat minus velocity of river. From this we write velocity of boat is equal to velocity of boat with respect to the river plus velocity of the river, right? So this is plus here. So velocity of boat with respect to the river plus velocity of the river. So that means now it is the resultant here. So the resultant of these two values must be only along these directions here. So for this simply what we are taking is, let us take this as x direction. So the components along y direction should cancel with each other here. So let us resolve this velocity of boat with respect to river into components, and velocity of the river into components along this direction and perpendicular to the direction here. So that you will get this equation here. So these are components there. So only this y component should be 0 now, because this perpendicular direction we are taking it as y component here. So this is our required condition here. So got it? So then when this condition is satisfied, and from this we can calculate our required value. Sometimes they may ask either alpha value or this remaining any values they may ask, like theta values they may ask. So that means then you can calculate just by using this relation. So that is the only concept here. If you want to travel in a particular desired direction, the velocity perpendicular to the direction should cancel with each other. The components of velocity of boat with respect to the river and velocity of the river. And so then let us see a problem based on this. A river flows with a speed of 1 km per hour. A swimmer wants to go to the point C starting from A. He swims with a speed of 5 km per hour at an angle of theta with respect to the river flow. If AB is equal to BC is equal to 400, at what angle the river bank should be swimmer swim? So that means now here the angle alpha they are asking here in our previous discussion. So then just we can calculate this velocity of man with respect to the river is along this direction. This is the velocity of the river here. So that means this angle is this is the direction here. This is the direction of velocity of man with respect to the river, or boat. Here man is swimming here. So then I am taking again man with respect to the river. So this is the direction of velocity of this river here. So velocity of boat should be along this direction here. VB value must be along this direction. And as this AB and BC values are given as same, so this angle you can take this as 45 degrees. And so this angle I can write this as 45 degrees here. That means in our previous discussion, this is our theta here. Alpha. This angle is alpha here. Angle made by this VMR with this desired direction here. So that means in this theta value is 45 degrees and alpha value just you need to calculate here. So you can use simply that equation there, right? So if we are using that equation directly here, so our equation is nothing but VMR sin alpha is equal to VR sin 45, and therefore the sin alpha is equal to, you can write this value as VR value is 1 km per hour and he is traveling with 5, and this is 1 by root 2. This sin 45 value is nothing but root 2. So from this we can calculate our desired angle here. So they are asking at what angle with the river, so with the river bank they should they are asking here. That means alpha plus theta value we need to write here. So this is a sine value. From this we can calculate this tan value, or I think here what they are taking is they are taking directly our desired angle as theta they are taking. So with respect to that they are writing here. Then you will get this expression theta value. That means that theta value they are getting it as 45 degrees to the river here. So that means now we are calculating with respect to this desired direction here. So then our theta value, required value is nothing but alpha plus 45 value, 45 degrees we need to write here, right? So simplify this. If you know already this value, you can write this, or otherwise from this you may find some tan value, or you can identify this value here. Try to identify this value. Then you will get this 53 degrees there, right? And this also such a similar problem. So this also, just I will explain this data. You can solve this. A man wants to swim in a river from A to B and back B to A. Always follow the line AB. The distance between points A and B is S. The river, the second, the velocity of the river current is V. Is constant over the entire width of the river. The line AB makes an angle alpha with the direction of the current. The man moves with the velocity U at an angle beta with the line AB. Then man swims to cover the distance AB and back. Find the time taken to complete its journey. So that means here he is traveling only along this direction to reach the opposite bank again and again coming back here. So the total time taken journey they are asking. So for that again what we need is, we need to find the velocity along this direction. So the velocity of the boat along this direction we need to find here, right? So if you find that value, then you can calculate this time taken as AB by the velocity of the boat, resultant velocity of the boat we can write here. So then that you need to multiply this value with the 2, because they are asking the total time taken they are asking here. So the total time taken they are asking, so just you need to multiply that value with that 2, so that you will get the time taken. This distance AB value is given as S. So directly no need of thinking about it. So S by VB into 2 we need to write to calculate this total distance here, right? So that is our time taken. So just to find this VB value. VB value means resultant velocity. After cancellation of this perpendicular component, find the parallel component along this direction. So that is our velocity of the boat we need to consider here. So solve this problem and verify your answer here. And now here, basing on this, I am going to explain one more problem here, and that means that exactly the same as that of riverboat problems. There will be another concept here, aircraft and wind. So velocity of wind will affect the direction of motion of this aircraft. And so now let us see this. All the problems based on this aircraft and wind are exactly same as that of riverboat. So we need to apply the same concept as that of the riverboat here. So there is, that means you can see this. This is similar to that of riverboat problem. Only difference is VBR is replaced by VAW, velocity of aircraft with respect to the wind. So that is the difference we need to observe here. So VBR, velocity of boat with respect to river, we are replacing with velocity of aeroplane or aircraft with respect to the wind. And velocity of this river is to be replaced with velocity of the wind here. So then VB is replaced by, VB is nothing but our resultant velocity of the boat or velocity of the boat with respect to the ground. So that is to be replaced with this VA, velocity of the wind, absolute velocity of the wind or velocity of the wind. So the same relation, like we know previously we are writing like VB is equal to, so VBR bar plus VR bar we are writing here. So similarly here VA bar is equal to VAW, velocity of aeroplane or aircraft with respect to the wind, plus velocity of the wind we need to write here. So just we are changing the letters, there is no other than that. So that means the similar concepts we need to apply here. So let us see a problem based on this. And so now here an aircraft flies 400 meters in still air and a wind, so that means it is 400 kilometers per hour in still air. Again here in still air means you need to consider it as with respect to air or with respect to wind, similar to the top of our boat. In velocity of boat in still water means you need to consider with respect to this water. A wind of 200 kilometers per hour is blowing from south. So that means it is blowing from south means you need to take from south to north. The direction of the wind is from south to north. So a pilot wishes to travel from A to B, northeast of A. Find the direction he must steer and the time of his journey. That means now these are exactly similar to that of riverboat problem. So now observe this. Velocity of wind is along this direction here, right? So velocity of wind is towards this north. So these are the directions what we are representing here. This is east and this is north. And so now velocity of wind is along this direction, and he wants to reach this point here. He wants to reach the point B here. So if he crosses, that means if he starts his journey directly along this direction. So suppose if you are assuming that he is starting directly along this direction, then because of the wind he doesn't reach this point. He will reach somewhere this point here. So because of the wind there will be some drift along this direction here because of the wind, similar to the type of riverboat problems, right? So that means in order to overcome this, the man should start his journey like this, not directly towards the point B here. So that means he should start his journey like this. The velocity of aeroplane with respect to this wind must be along this direction here. So that velocity of the wind is like this. The resultant of these two will be along this direction. So for this we are forming a triangle here. Observe this triangle clearly. The direction of this, that means if you want to compare with our riverboat problem here, so I can explain here. So let us compare with the riverboat problem here. So that means now here he wants to reach this point here. Suppose say this is point A, this is point A and this is point B. He wants to reach this point here. So if he starts his journey directly like this, we know he can't reach that point, right? So then for that reason what he is doing is he is starting along some direction like this. So this is the point C what we are taking here. He is starting along this direction here. So this is velocity of boat with respect to the river. He is starting this along this direction, and this is the velocity of the river here. This is the velocity of the river. So that the resultant velocity of the boat will be along this direction here. Got it? The resultant velocity of the boat is along this direction. So the same diagram they are expressing in terms of north and south directions here, so that you will get like this. So this is the triangle ABC what we are observing here. So BC is nothing but along the direction of the river flow. So here it is nothing but along the direction of the wind here. So then, so this is the triangle here. So now let us here they are writing this data here, velocity of the wind and velocity of the aircraft with respect to the wind. And now velocity of the wind must be along this AB direction here. The AB direction distance is given as 1000 kilometers. Now here just we apply this sine rule from this triangle here. In vectors I think you know the sine rule. In vectors there, or which is also called Lami's theorem. In vectors we can also call it as Lami's theorem. So let us see this. So just we are applying this Lami's theorem here. AC by, so this is our AC by that Lami's theorem. Sine of opposite angle. Opposite angle is nothing but just 45 degrees here. Next BC by sine of its opposite angle. Opposite angle is nothing but just alpha here. So that means that Lami's theorem, I think all of you remember that Lami's theorem. So that just we are applying that Lami's theorem here. And you can also write this AB by this angle we need to consider here, that is not required here. With this only we can calculate this our required data here. From this you can write this sine alpha is equal to BC by AC into sine 45. This BC by AC is nothing but actually you can replace them with this velocities here. Velocities, because this diagram we are representing in terms of velocities here. So these BC and AC values you can replace them with the velocities. So then from this you will get this alpha value as 45, that means 1 by 2, 30 degrees you will get here, right? Now our desired direction is nothing but they are asking that the pilot should steer the direction at an angle of 75 degrees 75 degrees from north towards east. That means they are saying this total angle here, this alpha 30 degrees we are getting here, and this angle is nothing but this total angle they are saying here. This angle they are saying here. This angle will be 75 degrees you can write here. Or if you want to answer this angle, then this angle will be 15 degrees. That means that 75, that means now the angles you can express now in different ways. You can express it as the pilot should steer the pilot at an aeroplane at an angle of 75 degrees east of north, or you can express this as 15 degrees north of east. This 15 degrees is the north side of the east. So 15 degrees north of east or 75 degrees east of north you can express there. And from this next we need to calculate this time taken. So to find the time taken we need now this VA value we need here. So now that VA value we can calculate this. Now we got already this alpha value here. So then this value we are writing here. So 180 minus of this 75 you can write here. That gives us 105. So that means this angle you can take this as 105 here. So that is nothing but what we are writing here. Say this. So VA by, again we are taking the Lamis theorem, right? So now the Lamis theorem we are writing here. So this is VA by this value we are taking here by this total angle 105, and VAW by its opposite angle sine 45 degrees we are taking here. So from this we are calculating this VA value as we know these angles here. Then from this after getting that VA value, we are calculating this time of journey here. The time of journey is nothing but AB by VA value we need to write here. So it is the time taken to travel that distance. So this is such a similar problem. So again try this problem here. Solve this problem. It's basing on the similar concept, right? So here the solution is also given. First by noting that formula, just to solve this problem, and otherwise you can go through that solution. So that means now these problems we have to practice based on this concept here. Riverboat problems or wind and aeroplane problems. So practice these 10 problems. So I am giving these answers also, so you can check whether you are solving, whether the answer is correct or not. So solve this, practice this all the problems here, right? So complete, that means with that we finished the riverboat concept and related this wind and aeroplane concept also, right? So next we will discuss another topic in our next class, that means rain and umbrella problems, the other relative velocity, relative motion concepts there, right? So that means I am closing this class now with this. Thank you.